Hello and welcome to the part 4 of the National Weather Service Pittsburgh Winter SKYWARN Spotter Training video series. This is video number 4 of the 6-part video series going through a Winter SKYWARN Spotter Training program. At the conclusion of this series, you'll be able to take our online quiz to be able to become a full-time weather spotter for the National Weather Service Pittsburgh office and help us during our winter weather operations. For this video, we're going to talk a little bit about the winter weather hazard climatology that we see across the upper Ohio River Valley region, and a little bit of insight on why some of this weather occurs. For snow, we use a 30-year sample data set to create our normal amounts. So this is updated every 10 years, so we kind of get a changing guard to see what's kind of going on. We can always use and look back at records prior to that 30-year data set, but that kind of is the basis for what we consider a normal winter season. So based on the latest normals, the average snowfall amount for Pittsburgh is 44.1 inches of snow through the winter season, which typically occurs between October and April, though sometimes, maybe get a flurry there in May. As you can see with this map, there's a little bit of a wedge of lower amounts that is across southeastern Ohio into portions of northern West Virginia. But those amounts grow and grow as you get into northwest PA, as well as into portions of western PA and kind of the north, kind of along the I-68 corridor of West Virginia into Maryland. We'll talk a little bit about why those amounts are higher in those regions. Also of note is the breakdown by month of some of these normal amounts of snowfall accumulation. As you see, our snowiest months actually tend to be in the New Year segment of the winter season in January and February, with the highest amounts typically occurring in January. Now, this is just an average over many years where we see most snow accumulating during this time. That, remember, does not mean, though, that a winter storm that can pack a punch of 6, 8 or more inches of snow can occur outside of that time range. It's just a little bit more infrequent of occurrence for those seasons. The other thing to note with these monthly breakdowns is that even as we get into what we kind of think of the springtime period, as you get to March and maybe into April, March can still be actually a snowy period for us, having an average snowfall amount for the month that is basically the same, just 1/10 of an inch less than December. So this kind of shows you that the winter season kind of drags into that March period time frame. So we know we always need to be prepared, even as we get into the springtime period, that we could still see impacts from snow. So why do we see those higher amounts in portions of northwest PA and portions of northern West Virginia along that I-68 corridor? Well, one of the reasons is because of lake effect snow, which kind of makes sense. We have this big body of water called Lake Erie that sits kind of along the border of Ohio, Pennsylvania, New York as well, that provides a moisture source for potential winter systems that come through. The key with creating lake effect snow and helping to really inflate or add additional snowfall accumulation for areas like northwest PA is this difference between the temperature of the water to the temperature of the air. So what occurs with lake effect snow is that water tends to cool a lot slower than the air around it due to its heating properties. Because of that, what we can have is a winter system that moves through, that brings cold air that flows right over top of that warm lake water, or warmer lake water. So when you have warm lake water with cold air on top, it creates this rising motion of warm, moist air that eventually hits kind of the terrain. It's not high, they're not mountains, but it's enough of terrain that creates an upslope motion that helps to create your clouds and eventually develop bands of snow. So what really drives this is this difference between how warm the Lake Erie waters are and how cold that area is going across it. What also matters is the direction of the wind bringing that cold air across. If the cold air is, if that wind direction is going the longest stretch or fetch of the lake, that's more and more moisture it can pick up to eventually dump once it makes landfall. If it's going across a shorter or a smaller radius diameter fetch of that lake, there's less moisture to be able to dump once it hits land. But these can still be very impactful snows that some of the most intense can drop upwards of 6 inches of snow per hour. We actually saw some instances last winter up in the New York Buffalo area of notably during the holiday season, we had this cold outbreak, but the winds were kind of out of the west to southwest as temperatures were dropping into the single digits while the lakes were still warm. That ended up dumping feet of snow in the Buffalo region. So it's something that then when you go to those average or normal snowfall totals leads to the higher amounts. The other thing that plays a role is called upslope flow. So the Allegheny Mountain Range there that goes through portions of central to western Pennsylvania into northern West Virginia are high enough terrain that helps to force air upwards. So what occurs with upslope snow is that wind is blown in a direction that tends to go up against the hills and it's forced to rise. The wind can't go around it, can't go do this and that, so it's forced to rise. This is called orographic lift. As soon as it rises, that moist air rises and cools, causing it to condense, which results in clouds and eventually precipitation. So when you have the right wind direction with enough moisture, you can squeeze out more water out of this scenario than maybe some other areas that don't have the terrain. So you have the combination of the orographic lift with moisture and cold enough air. You can have snow that is able to last longer and be more intense in these regions. And given that generally mountains and hills are a little bit higher up in elevation, they typically are cooler, so they can be maybe at the right temperatures to be more efficient with their snowfall accumulations. Based on the vertical temperature of the falling snow, colder temperatures at times can lead to higher accumulations mountain than some of the warmer temperatures that may be seen in the lower elevations. So these are the two factors that give those inflated or higher amounts of normal snowfall accumulation for portions of northwestern PA, as well as our higher terrain east and southeast of Pittsburgh. Wanted to also share this kind of graphic. This is just, again, an arbitrary look of a total seasonal snowfall accumulation for the Pittsburgh metro area. And these observations are taken at our office here in Moon Township. But wanted to note that, it can vary season to season. Sometimes we have highs, sometimes we have lows. So even though our average is 44, a lot of times we fluctuate around that 44 line. This is arbitrarily cut off from 1960 through this past season, the 2022 to 2023 season. And we've seen this fluctuation going up and down, up and down. So just note that even though the average is 44, we can see a lot of different potential amounts within that. So when we talk about snow, we're also we talk about frequency of these sort of events. When a winter storm comes through, how likely is it to be, we see X number of inches of snow in a given day? So when we look at climatology, we can actually calculate, here's how many events, how many times this occur. And it gives us an idea how frequently to potentially expect it. So in this table here, we can see that for any sort of snowstorm where we get at least an inch or more of snowfall in a day, we can expect that roughly about 13 times a year. For 6 inches or greater, that happens once every about 2 years. 8 once every 4, 12 inches once every 14, and 16 or greater once every 72 years. Now note, this is just based on averages. This does not mean that it's going to occur 13 times a year or every other year for greater than 6 inches. What this implies is the frequency with which it may occur over a long period of time. Within a single season, we could have multiple times where we have greater than 6 inches. We could have only 2 times where it's greater than 1 inch. It's not a predictor of what will happen, but it gives us a sense of how often these sort of events occur within the historical record, so we can put it in the right contextual framework. So just because we got say, a early season snowfall that was 12 inches of snow, that doesn't mean you can go through the rest of the winter thinking there'll be no more big events. It's not a predictor of what can happen in the future, so you always can remain prepared, but it gives you context of how likely it will occur. Some other quick snowfall statistics that might be of interest. These are all, again, based on the Pittsburgh observations taken here in Pittsburgh. The largest single season snowfall accumulation occurred in 1950 to 1951 of 80 inches. But a close third place was the Armageddon season of 2009 to 2010, where 77.4 inches fell. The largest single month snowfall was that Snowmageddon month of February 2010, with 48.7 inches of snow. The largest single snowstorm occurred back in November of 24th through the 26th, or around Thanksgiving of 1950, where we saw 27.4 inches of snow. The largest single day, calendar day, so that's midnight to midnight of a calendar day, snowfall was 23.6 inches back in March of 13th of 1993. And the most snow depth, so snow depth is how much snow is on the ground as of 7 a.m., was 26 inches on January 22nd, 1978. For some of the other frozen precipitation types, how frequently we can see it, these are a little bit blurry, they're a little bit hard to see, but the broad sense of the colors can kind of give you an idea. Areas shaded green is meaning you can expect roughly about 4 or more days of that to occur a year, yellow 7 or more days, and 10 or red 10 or more days. So for freezing rain, more often than not occurs in areas farther north, which generally makes sense. You need to have cold air at the surface. So the farther north you go, you're more likely to have cold air at the surface. But note that there's kind of this yellow bullseye, which is in portions of Northwest PA, but kind of it's around the Du Bois area. A lot of our weather patterns, and because of the terrain in that area, cold air tends to be able to hang in a little bit longer in that region, which makes things like freezing rain or freezing drizzle or even sleet more likely to occur there, because it's harder for warm air to actually get in the surface and prevent that from occurring. So note for each of those freezing rain, freezing drizzle, and sleet events, they tend to happen a little more frequently in those areas. Though it's outside our coverage area and outside for Pittsburgh, another area to kind of keep an eye out is portions of eastern Tucker into Garrett County, Maryland. They tend to as well have a little more frequency to keep that colder air in there to allow for some of these freezing rain type events. We mentioned in a previous video that one of the big hazards that can occur, especially as you go into the springtime, is flooding. So this is a chart table that just shows the historical flood crest at the Pittsburgh Point for as long as that we've had a station there on record. And again, these goes back into the early 1900s. What we basically want to focus on is not necessarily the observed crests, which they're all high and it caused a lot of damage and caused a lot of issues, but it's about the date. Note that the only crest that's occurred outside the winter to spring season, so kind of basically from December through April, occurred because of hurricane remnants that came up in June and back in 1972. The rest all occurred because of that combination of having rainfall plus snowfall melt plus ice jams, creating these historical crests on it. And they all occurred in the January through April timeframe. So keep that in mind as you go through as we get into that January through April timeframe. We have an increased risk based on historical data to have flooding issues during that period if we can get the right conditions in place. So that concludes this video on some of the hazard climatology that we see in the Upper Ohio River Valley area. Thank you very much for your time, and just check out the comments section to learn about the next video and how you can become a spotter with the online quiz that you can take at the end of this course. Thank you very much and have a great day.